This is lecture 3D for Calculus 1 on the derivative of exponentials. The rule for the derivative of exponentials is that the derivative of b to the x, here the derivative of b to the x equals b to the x itself times the natural log of b. For example, if you want to take the derivative of 2 to the x, you would have 2 to the x. Then you would multiply it by the natural log of 2, which is 0.6932. If you wanted the derivative of 10 to the x, you would have 10 to the x times the natural log of 10. The natural log of 10 is 2.3026, approximately, and then you would multiply that by 10 to the x. Since the natural log of e is 1, we have the special case. The derivative of e to the x equals e to the x. In other words, the exponential to the base e is its own derivative. Here are the proofs for the derivative of the exponential. The third page here requires that you understand the chain rule, which you might not know when you first look at these pages. You can, however, use the rule for the derivative of the exponentials and then return to this to understand the proof. Okay, so let's look at the first part of the proof. So we have a function that's b to the x and we want to take its derivative. The derivative of any function is the limit, as h goes to 0, of the difference quotient. The difference quotient is the function evaluated at x plus h, that's right here, minus the function at x divided by h. Okay, so when I take the limit, first I do some algebra, and get rid of some of the yellow stuff here. I'm going to take the limit. First I do the algebra. I can factor out b to the x. It's a constant multiplier. I can put that way out in front and just leave it there. Now I have the limit as h goes to 0 of b to the h minus 1 over h. This is a rather curious thing, and if I remember that any base to the 0 is equal to 1, I can rewrite the term under the limit as this: b raised to the 0 plus h minus b to the 0 over h. This might seem like we just changed a bunch of terminology, changed 1 into something complicated as b to the 0, but actually this is this buys us something. What is this? This is the derivative of b to the x evaluated when x equals 0. And that's what it shows right here. So this is another way to express the derivative of b to the x. In words, the derivative of an exponential at some x is the value of the exponential there times the value of the derivative at x equals 0. Of course, it doesn't seem too useful, since how do you find the value at 0? So we have to proceed to a few more proofs. Well, I just have to throw the word in here numerically, since we're not going to solve this right now, but numerically it can be shown that the derivative of e to the x at 0 is 1. This gives us two results. The slope of e to the x at 0 is equal to its own value, since e at 0 is 1. And also, the slope of e to the x is e to the x. Now remember, in this proof, all we had was the results from the previous slide. We didn't have that first statement. That's still coming up. We haven't proved it. So right here we can just show that the derivative of e to the x is e to the x. And now we'll go one more step further to get the statement we had on the first page. Let's review the statement from the first page. Okay, so here was a statement that we're trying to prove. The derivative of b to the x is b to the x times the natural log of b. And we proved this special case not as a case of this one, but standing by itself. And here is a second proof for, this is the end of the proof for the rule for differentiating exponentials. So again, we start with f of x equals b to the x, and then we do something which you will see again. We use the exponent. E raised to the natural log of b equals b. This will turn out to be very handy. So I'm trying to take the derivative of b to the x, and for b I'm going to substitute that exponential. So I substitute that right there for b. Okay, Now I'm taking the derivative. Well, okay, first I have to remember that exponent on exponent is the same as multiplying exponents. So this becomes the derivative with respect to x of e raised to the natural log of b times x. I'm going to take the derivative of that. But I have to use the chain rule. If you don't know the chain rule yet, that's a few lectures down the line. You can then return here. But like I said before, you can use this rule to take derivatives of exponents. But I'm going to finish this right here. Okay, the derivative of the log of b to the x is the derivative of e raised to the natural log of b times x. I know how to take the derivative of e to the x. That is just e to the x. So that term will just come out. Now by the chain rule, I now have to take the derivative of natural log b times, natural log b times x. Natural log b is just a number, and the derivative with respect to x of x is 1. So this is my result, and I remember that e to the natural log b raised to the x is just b to the x, and there's my answer. So we had a simple rule that will be very useful, but it took 3 steps to prove it, including the chain rule.